Hello Internet, in this video we are going to work on connecting lines or connecting 2 points by lines using a line render, but we're going to do it a little bit differently. We're putting some restraints on how we do that. And so we're only going to be able to connect things by straight horizontal, straight vertical, or diagonal lines at 45-degree angles. So it'll look kind of like a subway map or a train map or whatever. And hopefully we'll be able to create a line render that can just connect those however we want. At least that's the idea. But before we get to that, we had talked a little bit last week about doing some 3D model exports from Unity. And so this is the first example. It's the tower we were working on. The top broke off because printing points doesn't really work. But it worked, sort of. And the model I have there is an attempt to do a mini by like a minifig for like D&D or whatever, strictly by exporting a model from Unity. I tried to do a T-pose because I figured those would be hard. And so this is the result of that. That's the exact source, and the print is awful. It didn't really turn out. And a lot of that has to do with like clothing for games is literally just a line. It's just a wall of like tries, and that doesn't really print well. You need volume, so that didn't really work. Obviously fingers and stuff, and this model has like ear canals modeled and stuff, which is just overkill for what I need. But it was an interesting test, and I think there's some more stuff we can do with that, but not right now. That was just quick demo. We're going to skip out of that. And now we need to build 2 points. Let's just do it this way. A line render, sure. And so I think the easiest way is to do this in we're going to do this in 2D. The idea works the same for 3D. You just have to calculate the third dimension, which is just more work. So we're going to have point 1 and point 2. And so we should be able to get those centered like so. And then I want to create, this is sort of my playground project, so it's a mess. But let's just create a point connector project. I don't know what we'll call this. And so this is just going to be a point renderer. And so I think the best way to do this is we're going to stick a line renderer on here and our point renderer on there as well. Apparently needs to compile, so we'll give it some time there. And so the idea here is we need to figure out the shortest distance. And so effectively how this works is you connect, effectively you draw a box, a square, and that is your diagonal. And it will always work as that. And so the box is the minimum angle between the width and the height between the two. Then you put that in the middle, and then you connect 2 lines to either to the top and bottom or wherever, whatever point. And then once you connect those, then you have the diagonal in the middle, that's the rectangle. And everything else just kind of feeds into that, and it should just be super simple. I'm hoping it's super simple. Unfortunately, I do not have much time this week, so I'm planning on doing this video today, and then hopefully moving on and doing some live streams the next 2 days. So what I'm thinking for those live streams, since this is kind of taking its time, is it's going to be sort of like build a game in a stream. So like very truncated game jam. At least that's what I'd like to do. And so the idea is take ideas from you guys, whatever it might be. Maybe you want to see something like pogo jump or using like a pogo stick on a platformer or something. Just like base ideas or whatever. And we can kind of just draw all of that together, make a game. It'll probably be like 2 to 3 hours, so it's going to be a very rough thing. But the idea is going to be to try to build something that is playable in that amount of time. At least that's what I'd like to do. Depending on the ideas I get, it's kind of dependent on what you guys suggest, because I don't think it's as interesting if I just build something in 3 hours. It'd be interesting, but not as interesting. So if you guys want to throw suggestions in the comments, go for it, and then we'll see where that goes. More later this week, but there definitely will not be a video Thursday or Friday this week. Right. So we need to grab 2 points. So I'm going to do just transform 0.1. My computer is being extremely slow right now, and I'm not sure that's a good thing. Maybe there's a Windows update. It always gets really slow when there's an update. Okay, that took forever, but we're good now. Transform 0.2. And let's also grab our line render. And I'm going to have this execute in edit mode. And so if we have a point, or if there's not a point, actually this will be easier. If there's not a point, or there's not a 0.2, or there's not a line render. So this is a truncated way to do null checks. And if none of these are true, or if one of these isn't there, then we just want to exit out of this function. There's going to be a lot of me talking to fill space, I'm getting, because we shouldn't be having these kind of performance issues. I don't know what's going on. Anyway, that's going to kick us out. The other one is just going to be setting up our line render. So line render dot, let's say num points, or set positions. Sure. So this is expecting a vector, or a list of vectors. So we can just give it that really quick. And this is actually really easy because we're just using these transforms. So I can just do 0.2 dot position and 0.1 and throw those into a array, and everything's good. That should set up our line render, get its points working, and it should be working in the editor. So theoretically, once I get all this set up, our line render should update automatically as I move these points around. At least that's the hope. We'll figure out if that actually works or not. But if once we get there, then it's really a basic matter of actually calculating where these two things are, and then updating that line and actually calculating that square, so we can actually get the diagonal bit going in, because this is just going to draw a straight line between them. There's actually going to be 3 segments to each of these lines, unless it's directly in a line. So if they're straight along an axis, or directly parallel. I don't know if we'll get that optimization in there to actually pull out those unneeded extra segments, but we can try. Oh, come on, this is ridiculous. Anyway, going back to these prints while we're waiting for that, I have a really, it's a nice printer for the price, but this is like 0.1 millimeter precision, 0.1 millimeter precision, 0.1 millimeter precision. I'm still figuring that out, but I don't really know what I'm doing with this. So what I'm trying to do is actually, the next step for this project is to hook this up to Shapeways, I think. We'll probably be using Shapeways, but that actually has a, it has an API, so we can actually hook this up and actually upload the models, and then you could print, literally you could take a snapshot of your Unity scene and then upload it there. Like maybe you're debugging some cool action sequence. You could capture that, upload it, get it 3D printed, and then like 2 weeks later, get like a full steel print of whatever's happening in your scene mailed to you. And I think that'd be pretty cool. Okay, this isn't gonna work because they're right on top of one another, but if I move them, we get an updating line render, so we can actually kind of move this around. And if you really wanted to, you could actually extend this from a usability point. Instead of having to modify all of these positions manually, we could make it so that you actually get these handles that you can easily move. It's just a usability thing. So the next thing is making this not do that. So we're going to want a diagonal here in the middle and then two vertical lines. So I'm going to go from the top, and actually I'm going to drop a material on this because that purple is really annoying. Revolver. Gold? Gold works. That's kind of a lame color. All right. Sorry. It's very important that we find a cool color. Sure. That works. Anyway, so what we need is we need to calculate a rectangle. So if I actually get this into a reasonable position, I should have this at, 6. So what I would expect is this to go up 2, across, and then up 2 again. That's the behavior I'm looking for. So there should be a 45-degree angle here, and then it should look sort of like that, not like this. So that's what we're shooting for, and we'll see if we can get there. Draw a cornered angle, I guess. And so there's probably some sort of way we could represent this with math in order to actually calculate this in a way that we do not need to do all of this. Meaning we could actually figure out mathematically how to represent this for any angle. So like maybe you only want it at 30-degree angles. We could probably figure that out. But for now, I'm not so sure that that's worth it. So we're not doing that right now. But what I'm going to do is not that. Let's take in 2 points. So a vector 3 of 0.1 and a vector 3 of 0.2. And remember, even though these are vector 3s, we're only working on the xz plane. So y does not matter. And even if it did, it won't be different. It's just harder and going to take more time, and just that's not worth it. So 0.1 and 0.2. What we need to do is calculate we need the minimum and the maximum differences. So let's actually grab float x diff and the y diff. So this will be 0.1 dot x minus 0.2 dot x. And we're going to need the y difference, which is going to be 0.1 dot z and 0.2 dot z, which we should probably just make this z. That'll just be easier. But I was using y because x, y, 2D. Anyway, doesn't matter. We don't need that. Actually, we should probably, hold on. We're going to use y. And the reason we're going to use y is because when I click this, we would totally lose our points because we're on the z-axis. So if I put this on our y, okay, where'd it go? It's up there. We can see it again. And so when this means without any changes, this will work in a 2D game. For 3D, you'd have to make changes, obviously. But if you're doing this in a 2D game, this will get you covered. So that's why we're making that change there. This is the wrong project. It doesn't like that because it's not called and it doesn't return anything. We can fix that. And we're also going to want absolute values and signs. So I am going to take float min. Is this a good idea? Maybe. So what I'm thinking, this may not be the best decision, but we can actually calculate the midpoint. So vector 3 middle, and set this equal to 0.1 minus or plus 0.2, like so, and divide them. So this will get us the middle, the average of the two. And by doing that, we now know exactly the center of that square we're talking about. And so from there, we can take and actually draw to the x and the y, or the minimum of the x and the y. Grab the minimum, divide that by 2, and in each direction, draw it towards in the direction of each point. And we should be good there. So that should get us our middle bit. I'm going to modify this slightly and return a new vector 3 from here, just so we can see this working and see there shouldn't be any change yet, but we should be able to actually start rendering that middle there, so we can actually kind of see what's going on. So this should return our points. Then let's draw our cornered angle, which I don't know if we should call that draw because it's not actually doing the draw, but that's what we did. So we pass that in. It takes the points, dot position, got it. So we have to pull the positions out of those transforms, pass them into this, get our drawable vertices, and get this out. And so hopefully we should see a third position pop up here, but it should be at 1, 3. That would be our best case scenario. If we get something else, we're doing something wrong. It means that our division is not correct, which I really hope doesn't happen, because if it does, then I don't entirely know what's going on. This is taking way longer than expected. I'm sorry. Well, I think I'll just have to cut these out, because it's literally just spinning here and not doing anything. So I don't know what to do to solve this. Because like when this happens, it's usually just a Windows update. It's whenever I have an update waiting, my computer just stops. And I have not checked in like 2 days, so maybe that's the issue. But this is just awful. Ooh, that's new behavior. Huh. So we're still stuck to 2. That's interesting. Line render dot They've apparently deprecated the set number of positions. Set vertex count isn't there. So if we don't need to do that, like, this should fix it, but if I have to keep recompiling to do these things that I thought were handled automatically, that's a little bit annoying. Huh. Anyway, going back to, well, okay, awesome. This is working now. I don't know why we need to set that. That shouldn't be happening. And the fact that it is kind of concerning to me, because I don't think there's another way to change that. We can change the number of corner vertices and the number of cap vertices, which are going to add smoothing, like curves around the edges of corners, and the caps are going to make them round. But if we can't change our actual number of vertices without using a deprecated function, I'm so confused. I have to be missing something. There's no way they would have done that. So we're going to leave that. I'm going to use this function because it works and it's not strictly relevant. Use num positions instead. But this one's deprecated too. Position count. Okay. So they deprecated a function into another function or into another property, and then they deprecated that property into another property. That is Okay, we're gonna pretend like that works. But anyway, that's where we need to end up. Cool. So we need to figure out this rectangle or this square. So I think the next step is to find the 2 points on that square, because then we can draw 2 lines between those and 2 lines between them and the points, and then we should be good. That should be all we need. So I may not need this middle point if we're doing that. Actually, I think we can do this even in a slightly smarter way. And so let me think about this. Point 1 up. So the interesting thing is, I haven't done this before, so I don't really know what's going on. But I'm going to initialize these to just themselves. Point 2 up. And so these are going to be theoretically the points on our square. So there'll be a line connecting these 2 point ups, and then point 1 will connect to point 1, and point 2 will connect to point 2. So theoretically, if I do point 1 up here and point 2 up, as long as I get those set to the correct values, our line render is done. We just need to actually get this set to 4, so everything actually works. Then the fun part, we need to do if the math f absolute value of xdiff is greater than the absolute value of ydiff. So what this will mean is the y difference is less than the x difference, which means we want to use that. Let's actually flip this. If we're going for less than, let's say we're going for less than. So x less than y and y less than x. So that's what those mean, which means what we can do is do our xdiff is going to be the difference between the two. So if I take half of that, I can do 0.1 up equals 0.1.x minus 0.2.x. We want to, since our x is the small one, what we want to do, does this make sense? This might not make sense. Hold on. We're gonna need a middle point again. I shouldn't have deleted that. Oh well. Vector 3 middle equals 0.1 plus 0.2 divided by 2. So right back to where we were. Let's actually get these order of operations correct. Awesome. So what I want to do is when the x is less than the y, we are going to total distance or total difference minus divided by 2. So we want half of the total difference, which is going to be the x difference. So half diff, I guess. And let's take the x difference divided by 2 here. Is it best to do these both at the same time? We'll solve one and then I'll just copy it down below. That'll be the easy way to do this. So once we have half of the difference, this is along the x. This is our x difference, but I want to subtract this from the middle dot y, which sounds a little bit odd. But effectively what I'm doing is saying 0.1 up equals vector 3, a new vector 3, of our 0.1 dot x, our 0.1 dot y, and our 0.1 dot z. Now this is wrong, and I know that, but what we need to change is we need to subtract something or add something to this y. I believe, if I'm thinking about this correctly, it's subtraction here and addition on the other side. But I have not actually like drawn this up or anything, so I'm not entirely sure. But effectively what we're doing is exactly what I said of putting the square in the middle. We know that the square is short, or the difference is shortest along the x-axis, which means it's longer along this axis. So the square is going to fall somewhere in the y-axis. And so what I need to do is actually move that in the y to get it halfway there. And so what I'm actually going to do is use the middle position here instead of the points, and then add and subtract the half difference to actually move it. So if I got this correct, what's going to happen is it's going to look sort of like a kind of like lightning bolt or a Z. If I got it even wronger, it's going to be very pronounced and look more like an N or something like that. So we should be able to copy this down here quick and just duplicate it. Since we're working with y on this side, we need to do that. And then instead of doing the middle as the y, we need to do it as the x-axis. So middle.x minus our half diff, and middle .x plus our half diff. Now, since we're not using the absolute value here, this should work regardless of position. So if it's wrong, it will be wrong everywhere. If it's right, it will be right everywhere. That's sort of why we're doing it this way, hopefully. At least all of this is theoretical. It's just, I literally came up with this in my head. So we're going to see what happens. But that should be all of the code we need. That should never be uninitialized, so we should be good. Yeah, I'm about 20% confident. So we'll let this compile and see what happens. That probably will take a bit, but we'll see. But we should see something happen, and then we can test all the angles and make sure. Oop, no, that's not half, but it's a thing. We seem to have moved things. I am using, there we go, the wrong thing to manipulate that. That's not what I wanted. Oh. Oh. Interesting. I may have flipped those. Yeah. Let me quickly just move those across, because I suspect I may have flipped them, because that doesn't look correct. It looks like we're calculating this totally wrong, but I don't think we're too wrong. I think it's just somewhat wrong. There we go. You're doing it wrong again, but huh. I don't know what causes that. That's interesting. We may have to dig into that, but this is right. And I should be able to, oh, it gets flipped. And that's wrong. Okay, so it works in a total of, oh, like an eighth of the map. That's somewhat successful. What have I done here that would have caused this? Huh. I don't entirely know. Oh, ha. Why are we passing in the Z here? That's not gonna work. That's part of our problem. So let's take that out and see if it changes our answer a little bit, because I suspect it probably will. So that would do it. Typing. We all are terrible at it, but whatever. Nobody's come up with a better way. That's not going to do it. There we go. And so this is sort of the N shape I was talking about, where we've done it on the wrong side. And we should just see that in every place. Yes, awesome. And so that means I get to go, ha, I was correct the first time. I just had zero confidence in my mathematical abilities, but that's all right. We'll get there in the end. So this should work. And if it doesn't, then, well, we'll fix that. But hopefully this gets us to the point that we need to get to. So this should go down now. Or there we go. Yes, awesome. And now it looks all smooth. Oh. Why do I always have it set up in a way so it looks correct from a single point? So this is correct. That's wrong. That's correct. That's not doing what I anticipated. Because I would expect, since we're not changing the difference here, since we're not flipping the sign or anything, I would expect it not to be acting in that way. I would expect it to stay consistent. That's clearly not happening. And I wonder if it has to do with needing to flip these. It might. So how can we fix that? Absolute value? I don't think that'll do it. Let's see what happens, actually. I'm curious. I don't think this is going to work, but I'm curious what the visual result will be by just taking the absolute value of this half difference. If this works, I'm going to be very confused. I suspect it'll just make us wrong more consistently because we won't be adjusting for scale at all. Because the difficult part is like over here. This is going to update, but anyway, over here you have a point. On the other side, it needs to go in the opposite direction. And so detecting this angle, that's the hard part that's kind of catching us right now. And we need to figure out how to fix that. And I am doing a really bad job of it. So, well, this isn't a good sign. Shoot, because I did not save. I will be right back. This might take a bit to recover. So, one sec. All right, we're back, I guess. It's still broken. Like this looks right, but it isn't. Well, that looks right too. And that looks right. One sec. Nope, that still broke. Okay. So X, it seems to be that it works for negative Y. So when the Y is the short side, that works. And when the X is negative, that works as well. So we have created one that works for negative values and breaks for positive ones. So we need to invert it for positive anything. So as long as both of the diffs are negative, we're good. If it changes, it doesn't work. So what would cause that? What if, so if I do this, this is wrong, but this should invert it. So this should work now. I'm like 95% sure. And if it does, I think we can fix it. Yes, awesome. So negative values are broken now, which we should be able to fix by multiplying this by the sign. So if we remove that absolute value, I was about to just do multiply by the sign. So there's a math function, math dot sign, not sign as in woo woo, but sign as in like plus or minus. And if you do that, it will return -1 or +1 depending on if it's negative or positive. We can just remove the absolute value. I don't really know what I was thinking there, but apparently I wasn't. So since it was working for positive values with absolute value, this isn't going to affect that at all because it's an absolute value, which is only going to affect the negatives. And since negatives were working, this ought to work. Except when they're one of them is not. I'm gonna need more time on this, unfortunately. I'm not sure. Let me go think about this because I need to draw this out. Just poking at this is not working for me. We're close, but it's just outside of where I think we need to be. So let me look into this a little bit more, see if I can come up with something, and hopefully we'll get this everywhere. And so that will be probably in the same video. I'm gonna probably hold this back a day, and then we'll see what happens. But yeah, I guess you'll probably see this the same day as the live streams tomorrow. But oops, I guess. This is poor planning on my part. I don't think there's a way around it though. So yeah, this will be coming out hopefully around the same time as those live streams, I guess. But hope to see you guys there. And I guess that's it for this part. I will hopefully have an edit right behind. There will be a jump. And then I will be back and we will know what to do. This is annoying. Alright, well, cool. Till then, see you, internet.